So I want to show you how to take an existing program and organize it into functions. Functions are just an organizational tool. As your programs get longer, and it's not uncommon for a commercial production program to be hundreds of thousands of lines of code, it needs to be organized. And until now, we've been doing everything in the main function, in just that one function. But ideally, your main function should almost be an outline of your program, and then the details of that processing should be isolated in functions, just like Excel. So I'm just going to run this program for you so you can see what it does before we go and modify it. So this program is for a tea shop, and we are calculating shipping. And the shipping is based on the cost of the order. So if the order is high enough, there is no shipping cost. Let me do another one. So let's have 2 ounces, then it's $2.50. Then I get shipping charge of $5. This program loops around. So what I want to do here is I want to take the part that calculates the shipping cost and isolate that in a function. So the shipping charge or the shipping cost is based on the cost of the tea. I'm going to take this long if-else statement and I'm going to move it into a function. So I'm cutting it out. I'm putting a comment where I took the code from, because that's where I'm going to actually call this function. So I'm putting a comment there. So the comment call function is where I remove the code. Now I'm going to put this code at the end. Your functions have to be after main. They're separate. They're modules, separate little chunks of code. So every function I do it needs to say what type of data it's going to return. This is a shipping charge, that's currency, so it's going to return a double. The function needs a name, and I'm going to call this calc shipping. And then I can put in here data that may be passed to the function, but we're going to come back to that. So I'll show you there's like a little trick to this. And then I'm going to have my beginning and ending curly braces that mark the beginning and the end of the function. Okay. And then I'm going to take that code and I am going to copy and paste it right into that function. So that's pulled all that code out of my main function, and it's after main. So don't try and put your functions inside of main. They don't get coded in main, they get called in main. So the code goes after. Now when I do this, I can come down and I can look at the variables that are here. And I have to decide how the values are going to come into this function for those variables. So if I'm looking at shipping charge, I can see that shipping charge is really calculated here in this function. It's not coming from main, it's actually what I am going to return to main. So I'm going to declare that here in the function. But the cost of the tea, that isn't produced anywhere in this function. The cost of the tea, the calculation for that, is up here in main. So that means I need to send that data. It needs to be input. So that gets described here. And it can have the same name as the variable in the main function. It doesn't have to. They're two separate variables. So here I have a variable local to this calc shipping function. its name is shipping charge. There's also a shipping charge up in Maine. Different shipping charge. So there's calc shipping charge, and there's Maine shipping charge. There's calc shipping T cost, but there's also a Maine T cost. So they're kind of shadows of each other. It's just how they're going to get their values. The value for shipping charge is going to be calculated in the function. So I'm declaring it here. That's how it's getting its value. This T cost is going to get its value when we call the function. So when I tell the program to call the function, this variable will be created and it will be initialized with the value of the variable in Maine. Now, I need a prototype, which is the declaration of the function. So I'm going to take my function header, and I am going to paste that above Maine and put a semicolon there. So before you can use a function, you need to declare it. Just like before you use a variable, you need to declare it. And then when I come down here, this is where I'm going to call that function, where I took the code out. And that function is going to produce a shipping charge, Maine shipping charge. So I'm going to say shipping charge equals, so the variable shipping charge that belongs to Maine is going to equal the result of the calc shipping function given the T cost. So when this function is called, when calc shipping is called, it's going to initialize the T cost in calc shipping with the value of the T cost in Maine. Okay. So it seems like a lot of work to end up with the same answer, you know, and I can't argue that. But what you gain is readability, modularization. We can also take something, let's see, we have some duplicated code here. We have this controlling variable where we get that wire n thing. And we have that twice in this program. So really, we're not doing any error checking with this. We have it twice, we have the prime and we have the update read, but we're not doing any checking with it. So I'm going to do the same thing. When you have duplicate code, it's a good idea to put it in a function. So we have that same code twice. So I'm cutting the code out of there, and I'm just putting the note in for myself so that I know to put the call back in there. Okay, so I come down after the calc shipping. Okay, so after Maine, after calc shipping, all my functions get coded at the end of Maine, and they're separate from each other. So a lot of times people confuse the coding of the function with the calling of the function, and they're two separate things. So this is going to return a character, that wire n, and I'm going to call this, I don't know, get yn. And this one I'm not going to send, well, I'm going to leave that blank. We'll figure out if we need to send anything there. I don't think we do. And I'm going to put this code in here. And if you remember from chapter 8, we should always check our input. So let's put this thing into a do while, which makes it a lot longer. end, I'm going to return that because I've forgotten the other function. Okay. So if I look at this function, okay, I've got my prompt, I've got my variable, I only have that one variable, that yn. And that yn, I'm getting it as inside the function. So its value is coming from some kind of calculation that I'm doing in the function. So I don't need to pass anything. I only have that one variable. I don't need to pass anything. So I don't need to have anything here. I mean, you don't pass anything, you can put void in. That's optional, but it's not a bad idea. But I do have to clear the variable in the function because we have the concept of local variables. Variables belong to the function in which they have been declared. And at the end, I'm going to return yn. On this one, at the end, I have to return calc shipping. So you're going to return whatever it is you calculate. I'm going to return shipping charge, sorry. So at the end, whatever the function produces, and a function can produce one piece of data or no pieces of data. That no pieces of data is the void function. We'll do that in the next chapter. So I have my function. I need a prototype. So I have to come up here and put my prototype, which is a function header with a semicolon at the end of it. And now I can call it. So here, whoops, sorry. Instead of all that code I had, I can just say yn equals get yn. So this variable here in main, the variable yn in main, will receive the result of this function. So it's calling this function and it's assigning the result of it to this variable. So that's a lot of code that I can pull out of my main function. So my main function is getting smaller. That priming the priming read and the loop read here have been brought down to one line of code. So my main function gets smaller. It becomes more of an outline. I don't have as many of the details in main. Those details have moved to my functions. So it's an organizational tool. Again, it's not going to look any different. Your output should not look any different. Okay. This is an organizational tool, a behind the scenes type of thing. And this is your first step to object-oriented programming. First step in the past. So just let me try this. It should look exactly the same. Well, I'm going to have the error checking in it, so you know, they can enter the wrong thing. And we'll make them re-enter. Okay, looks the same. So that is functions.